So I would like to
Yeah.
move on to the next speaker. So with the advent of modern technology, so our first speaker was from Australia. Our second speaker is on the other side of the globe. So she's she works in Intel right now. So I'm very honored to introduce Dr. Shamima Najnin. She also completed her BSc Engineering from BUET, and she completed her PhD in ECE from University of Memphis. And she's currently working in the Intel Corporation as a software engineering manager. So her research interest is in deep learning or AI. So I would like to invite Dr. Najnin to share her talk with us.
So as Sajid introduced, I worked in currently at Intel. Previously, I completed my graduation from BUET and then PhD from the University of Memphis, USA. So my current focus is AI or deep learning performance in hardware side. So let's get started. So first, let's look at where is the deep learning position nowadays. So previously, artificial intelligence is a broader category. And during 1980s, machine learning is becoming popular where people can program it and then make people's life more easier. From 2010, because of the variability of application uses in deep learning, this field became very popular in different areas of research areas. So I am just putting few applications areas here. Categorized is computer vision, speech and audio, natural language processing. For each broad category, we have many applications that we can cover on. So let's take a look hot at the applications and how we are using current days. So this is the classification. In your mobile, if you see in backside, sometimes shops or outside, if we don't know what the material is, you can just take a picture on your phone and using your app, you can just know that what is the object you are looking at and all the information about it. One other important part of the application is object tracking or object detection. So if you see here, police is tracking a stolen car. So this is a real-time case, and for security cases, these are really very important. Then next come to medical imaging section. Now for medical imaging cases, doctors can use nowadays 3D tool. Also they can do offline or remote consultation. All of those possibles now because of these applications. Now popular one came for speech recognition. So nowadays for our mobile, everybody have voice recognition, speech recognition system that we can use easily. In our home, a lot of people use Alexa, in Apple phone, Siri, Google now, Cortana, to get as a voice assistant in our home. You can give the direction to them, you can get weather information, you can play music. So that makes life more easier. Now, a lot of companies or website or customer services, you will be seeing some virtual assistant. So this is also an application area of AI side where you can do the virtual assistantship. Another important work is natural language translation. So from English to Bengali, Bengali to English, even a lot of language support is there nowadays for this translation work. Still, there are a lot need to do to getting it more accurate and accurate. Now, recommendation engine, if you see Amazon, Facebook, Netflix, YouTube, you will always see some ads what what you want to bought, what people bought. If you go to YouTube, it will always so show your recommendation based on your choose, personalized recommendation. So this is also a great application area of AI nowadays that is feasible. So let's look what is the behind it. So we have different kind of software stack. So in there, a complete set of tools are there, frameworks are there, libraries are there. And behind that, what it is running on top of that, that is the data center hardware. Now let's look at a little bit more detail. So I have summarized the application area. So these applications actually covering neural network configurations. There are many more industrial frameworks now that you can use that make the developer life more easier to get this application working. And behind this framework, you have another layer that has different libraries. So these are basically math kernel libraries where you can do matrix multiplication, convolutions, additions. Those are software library. Next level is where we are doing all of these, those are in hardware. So CPU, GPU, FPGA, and ASICs. Now, what kind of hardware we can choose based on the application where you need and what is the performance you require. Based on this, you can choose your hardware. So my focus is mostly on CPU side. And here we are using the library and developing the library of 1DNN. The reason of using CPU is it is a general purpose computer and flexible. Sometimes we all use computers in our home. Even in the server side, all industry are using a general purpose computer. So if we can make AI specific general compute processor, then it would be helpful for other application as well as AI. So with this whole stack, what we want to do? First, we need to have the correctness of the model. So any computer vision, speech, audio, or natural language processing, any application we take, we need to make sure it is meeting the accuracy as much as possible. Then in this whole stack, while you go from here to here, we want a fast processing. So say for example, if you go to a shop and you take a picture and you want to know the product name and its description, if it takes long time, the user may not be enough satisfied. So not only the accuracy of this part, we want to have in whole stack the performance fast as possible. So that's where correctness of the model come, and then performance of the model come. Now for deep learning part, there is two cases. One is training, while you are actually learning the model, and second case is inference, where your model is trained, you will just send the image and it will give you the required info for it. So for inference also, this is batched inference, and another one is real-time inference. So batched inference is called while you send multiple images or multiple requests together, and real-time inference, you will get a single one and get the feedback concurrently. Now, what are the performance optimization scope here nowadays? So every layer I have mentioned here, every layer you have scope in the performance optimization. So first case in model optimization. So in the deep neural network side, you have the kind of technique called pruning, dropout, where you can remove some unnecessary part of the model. Also, you can do graph optimization of the model that can give you some software acceleration. Next one is framework optimization. Now, framework optimization, so nowadays there are a lot of industrial framework as well, TensorFlow, MXNet, PyTorch, Paddle, OpenVINO. So these are also another scope where you can do the framework optimization. Third one is library side optimization. So what I told that 1DNN or CUDNN or eigen, every library, those are basically math kernel library where you can do the primitives more faster. Like you can do a matrix multiplication algorithm or convolution algorithm or summation or addition as much as possible. The second category is where the focus is low precision hardware acceleration. So currently, if our computers you saw, you can see that it's the 64-bit computers, but we generally, all of the deep learning or neural network parts, those are using floating point 32-bit. So this part is general case. Now, what are the options we have currently available that we can convert your data size 32 to 8-bit integer side, that you can get the higher performance. The next case, we can also do 16-bit cases where you will get also the better performance. Now, what is the advantage of using this lower bit? So while we consider industry level, a data center require a lot of amount of power. Also, it requires enough memory bandwidth. It requires storage. So in combine all of those, there are a lot of resources required, and we need to optimize those resources as much as possible. So these, if we do lower precision, we can save in these areas. Now, for CPU processor, we have different kind of features for doing low precision support. One is called AVX512. So in our computer, generally it's a 64-bit. Instead of 64-bit, we have the 512-bit register, so that you can do more computations parallelly. These can give your boost. Then so for 8-bit integer, what we are working on, we have the VNNI feature that you can get to the 8-bit integer support. And the next one, the recent one, has both the data type, precision VNNI and bfloat16 support, so that can give you both. Now let's see what are those performance impact. So if you are floating point 32-bit precision, so your accuracy would be high. While it is always a trade-off, once you are making like accuracy lower and you are making your precision lower and lower, your speed will go up, but accuracy also get lowered. But we may not want to lose the accuracy. So that's why a good role play is bfloat16, where it can reserve the accuracy also, and it has some performance. There are a lot of active research is going on how we can do a trade-off between accuracy and speed. We want to have maximum speed possible by keeping accuracy fixed. Let's see what I talked about those features, how it can make the performance delta. So this is a computer vision performance on ResNet 50. So this is previous processor. Now, while we are using AVX512, vector extension bit 512-bit register width, we can get for training around 60% improvement. Now, In the second case, also this generation, this is also using if a register 512 AVX register. So there also we are getting 64. Now, third generation, where we are getting 82%, and where we have additional support of lower precision bfloat 16. While we see this is almost greater than 3x performance that we can go from here to here. For inference case, if you see with lower precision, with 8-bit integer, that is called int8. So we can see 3x performance. Then the next generation, where we have again int8, that is VNNI support for 8-bit integer, FP32, while you are doing lower precision, then we are getting 6x. Now, third case, where also we are getting around greater than 6x, and for bfloat 16, although our performance is little lower, like 3.6x, but accuracy wise, bfloat 16 is, if somebody is very sensitive to accuracy, then bfloat 16 is a preferable option. Now, what are the key areas we can focus, and still there are a lot of challenges in there. So one is model development, how much accurate we make our model, what we talked, natural language processing, say English to Bengali translation. If you now go any app and do the translation, it may not be as good as we want. So there are a lot of scope where we can improve in those areas. Now, for in software layers, like I have shown frameworks and libraries, there we have a lot of tools. So making those tools faster is another key research areas. Now, I have shown 3 precision where we have a trade-off between performance and accuracy. So this is another research category where we can do mixed precision, where FP32 int8 or invention of new data type that can give us better accuracy with the performance. Also, one other areas is based on the use cases like speech recognition or computer vision or language translation. For those kind of, based on those cases, performance optimization varies. So we need, it's a good research area also, how we can make some generalized performance. So these are the key areas. Those are open, and we have research opportunities still to work on. So that's all from me.
Thank you so much, Dr. Najnin. We have a couple of questions for you, but we would be taking the questions at the end of the session. And
yeah, sure.